Hello, hello. All right, we're live. Hello, everyone. I'm Brian Fahey, an engagement manager with Akamai in the media and gaming customer services group, joined on stage by John Councilman, who's an enterprise architect with Akamai, and Eric Klein, our client from BAM, known as BAMTech. BAMTech, for those of you who are not familiar with BAMTech, they've been a leader, a pioneer in streaming since 2002, starting off delivering infrastructure and streaming services for Major League Baseball. And they've been pioneers in the industry since then, so proud Akamai customers from the beginning. During today's session, we're going to talk about three exciting things. We're going to talk about how BAM originally was provisioning CDN configurations on Akamai. We're going to move into this concept that we call the golden config, which is basically a centralized location of optimizations for CDN delivery. Then we're going to wrap it all up with the API integration that we've done to automate this and make it possible for BAM to scale their business and all their live workflows. So, how did BAM used to deliver CDN configurations on Akamai? Well, it was a very manual process. Traditionally, CDN configurations were very unique. We had hundreds of them. There was a lot of custom metadata. I'm sure most people in the audience can relate to this. The organizational kind of nightmares in managing complex configurations that are not standardized and have a lot of variables that are implemented in different ways. Features and functionality that are really requirements of their customers' businesses, but it's implemented in metadata in very different ways. So no standardization. This did have a lot of benefits we'll go into. This was quick. BAM could easily spin up configurations, really ad hoc. It could be very customized. There was a lot of benefit to this, and in their speed to market and being able to deploy a lot of neat custom features, but everything was unique. Configurations were snowflakes, and they were so specialized that testing the configurations and really scaling it was difficult. So there were a lot of benefits, a lot of challenges as well. Eric, if you have...
Yeah, just to add to what Brian was saying, there was significant overhead to maintain these. Our configuration growth grew to over 500 or so configurations, all of them driven by this reactive methodology. Every time we had something, we had to create a brand new configuration that borrowed from the previous configuration. And I'm sure a lot of people have those type of challenges and problems, but the result was that with self-service on the horizon, with the DevOps kind of needs that are being championed here at Edge, we ran into a challenge. How do we leverage that? How do we use that? And ultimately became a blocker for us to be able to get to the next level and leverage those existing tools at our disposal. And so
one other factor, clone was used significantly in this workflow. We take the last best known configuration for site and for streaming now, and we'd clone it because it had the optimizations that work best for our origins, and that's really where we versioned and we iterated on those last known good configurations. But there are challenges with that, and that's where we came up with the concept now of the golden config that Eric's going to be going into, which we came to through analyzing hundreds of configurations in our environment with the professional services team and Eric's team, and really came up with a standardized list, really a reference architecture for us of optimizations, caching settings, and options that Eric's going to go into that we wanted to make sure were enabled in every single configuration we deployed in production.
Yeah, and so the golden config concept was driven out of the fact that we had a couple of standard products that we leveraged, a couple standard feature sets we leveraged, some standard content characteristics, geographic characteristics that defined all of our configurations, some origin characteristics and advanced overrides that we used, some security needs and options that we used, and some tier distribution things that we used. But really, to get a sense of the kind of chaotic nature of what led to ultimately be able to use this golden configuration, I think it's good to walk through or maybe even whiteboard for you what we used to deal with and all the different inputs we used to deal with. And so to give you a kind of sense of that, I'll jump over here and just kind of draw out for you kind of the world I walked into about a little over a year and a half ago and some of the ideas we had. So, let's start on the origin side of what we dealt with. We had origins on the East Coast of the US, Central US, West Coast. We had origins over in Europe that we have to deal with. We have origins in net storage, and then other cloud storage providers. I'm sure everyone kind of has all of those that they're always dealing with. And these origins are just some of the initial inputs that we had to worry about in this golden configuration environment. On top of that, we had a whole host of optimizations that we considered for each and every configuration we did. So we had origin pathing that we worried about. Are these going to be specific aspects of the origin that we're worrying about hitting? Do we have to cut out certain aspects of the directory? Are we going to have to set up cascading timeouts as part of things? Do we need to make sure that we're cutting certain aspects out of the configuration so that we're skipping certain aspects of the mid-tier so our origin isn't getting crushed by too many requests back to origin? We have to make sure that we serve objects when they're stale. I'm sure these are standard things that everyone enables, but if you're constantly going through and cloning iterative configurations, you might sometimes forget to enable those or have to consistently include them, and we wanted to make sure that they were part of all of our configurations. Something that we'll go into a little bit later, forward serial hash using AK path is something that we found that we really required as part of all of our configurations. It solved a big problem of ours, but it became crucial to all of our configurations moving forward. We use what we call blessed headers for some standard content security, nothing too crazy, but just one way we secure some content. Redirects that we might put in place. 404 TTLs, right? Timeouts on stale objects and different types of caching here. Then on top of that, we had different characteristics to the content. And forgive the handwriting. As we all know nowadays, it's all keyboard and typing in terminals, but the pen and the whiteboard sometimes still come in place. So we'll handle different geographic delivery with our different characteristics. We'll handle IPv4 and v6 setups. We'll handle different HTTP and HTTPS configurations that we have to worry about. We have protocol downgrade, something that's really near and dear to our hearts, and as you can certainly ask all the different Akamai product managers that have come in to our path over the last 2-3 years. We have to worry about audio-only configs, web-only configs, still flash, which I'm sure, many people would still say to. And even just timing on the media, some of our segments being 5 seconds, some of them still being 10 seconds, and even some of them being set up to be 2 seconds or less. We had features we worried about, tokenization to secure our content, and other content security mechanisms that we used. And then finally, just the standard product types of Akamai. AMD, HTTP download, MSL, media delivery, the list goes on. It's just a whole host of different setups that we leverage, that we needed to use. All of this kind of creating a chaotic mess, my handwriting aside, kind of became problematic for us to leverage and use as part of our setup.
As you can see, complete chaos. This analysis, although we're writing it out, and it actually looks a lot more logical than it did when we were originally collecting all these variables that we knew needed to be standardized. Sorry. So we're saying that most of these features and these options that we're talking about, took a lot of planning, a lot of testing with the account team to look at across the configurations, where we were implementing and focused on these different variables. But now we're going to go and show you how this was all organized with the golden config.
So just one outcome of this too, just to tell you, before we even got to this kind of matrix, we were looking at a matrix in a spreadsheet that was, I think it was about 700 or so different Excel lines that we had to get to just cull through these different aspects from our different configurations that were existing, all of them from previously XML metadata. So it was quite a lot that we had to go through before we even got to this point. But where we got to today that enabled us to eventually get further, and that's to the golden configuration baseline, if you will. That baseline template for our golden configuration that enables us to pretty much make everything we need to for our work and publish a new configuration within about 20 minutes. Get something up there, out there, ready, in staging, and good to go for our testing and our deployment for all of our different partners. So we start for that configuration template with kind of a few different options and a few questions. First of all, we ask, what's the type of content that we're delivering? And that's pretty simple, right? Is it media? Is it a web? Or is it just our legacy media configurations? And for that, in Akamai terms, we'll call it, is it AMD or is it HTTP download? Just two different ways that we differentiate them. The next one that I'll ask about is it the type of origin? And that is really pretty simple. Is it ourself, or is it net storage? And then finally, also, we have to ask ourselves protocol. And that's HTTP, HTTPS. Something to keep in mind too, we always handle with HTTPS for our media protocol downgrade. So everything that we handle on the edge of our network we'll handle through SSL. But everything that comes back to our origin, we handle through HTTP. We verify that it's the CDN talking to us before we go ahead and respond in kind. But it enables us to handle a massive amount of scale of traffic without having to issue an additional cert at our origin. And for us, it's how we work with all of our different partners in the delivery space for CDN. So, how do we go about and provide these inputs, though, was really important to us. We wanted to simplify that as much as possible so that not only did our infrastructure team, which is the team that I'm a part of, not only are we the ones that could enable these CDN configurations or that our core media team could do these, but that our operations team or even our media operations team, those that are kind of in the thick of it, monitoring the events, they could quickly spin things up if we really needed them to. And so it was pretty simple. It was a couple of inputs that we had. Origin, publish name, how we published it out, the CP code, which I'm sure everyone's familiar with, and which partner of ours was it. And that was kind of defined by a folder structure that we put in place to organize everything. And then the final options that we asked ourselves and ultimately came to, which took advantage of the property manager variables and which kind of goes into the APIs and enabled us and kind of what drove us to use the property manager APIs versus Akamai CLI or any other options we had, were the ability to use these flags to set these variables. And so that was tokenization, geographic options, so which geo regions are we delivering to and from, the tier distribution options that we had, is the content live or is it video on demand? And then also segment duration, right? Something we talked about before, but something that constantly can change. And so we wanted to make sure that this configuration was adaptable, adjustable, and configurable for the future. So pretty simple, nothing too complex, but when you're dealing with 50,000 live events and you're dealing with hundreds of configurations that need to be spun up really quickly, we needed to simplify our workflow, simplify all the different options we were dealing with, and bring it down to standard baselines that we could work with. And so that's kind of where these the golden configuration template came from and enabled us to kind of drive our workflow forward and ultimately get to the use of the API. It also, though, helped us solve a long scale problem that we had. And so some of the benefits that came out of the golden configuration, as we talked about scalable, right? It gave us a single source of truth. It enabled us to provide organizational improvement and enable other people on our team to spin up configurations. Rather than our customized options, we now had a variable-based template. Very quickly, we can spin things up. create new configurations, create new adjustments, and when we made a change, it all went back into that variable single template. So it wasn't a constant need to track changes and consistently change and modify things again and again. It was always going back into one single source of truth. Finally, though, it did enable us to solve long-standing issues we had. One of those things was excessive requests back to our origin. That's something that really was a major pain point for many years with our Akamai configurations. Whether it be when there was a lot of traffic on the edge and we had issues at our origin, and then the edges would come around those origins and come back to our origins to kind of fulfill the requests that the customers were asking for, or it would occur because we would just have the origins at Akamai having to hit mid-tiers and those mid-tiers scale out appropriately. We need to figure out a way to solve that. And in order to do that, the golden config gave us a window to finally view how we can make that happen.
Yeah, and just to add to Eric's point, doing this again at scale across every configuration that we had and have the confidence that we've deployed these types of optimizations in a standardized way just gives us the confidence to do live events, knowing that our on-site origin is going to stand up, and we're actually going to be able to maximize the number of events that we can serve from that origin because we have full confidence in that the requests and the bandwidth are not going to take it down.
So to that point, we brought out the excess request to origin in a deep dive. Just really quickly, we talked on why that happened. So really quickly, how did we solve it? We talked about that collaborative approach, how the back and forth really helped solve it. But one of the things in specific that we want to talk about, and that came across, was the golden config enabled us to identify the use of forward serial hashing with AK path, Akamai pathing, and what that enables us to do is basically a specific use of predefined server sets within the Akamai network that might increase the concurrent connections back to origin, but what it does is it scales that up to enable you to reduce the overall volume that is coming back to origin. So when you're doing massive amounts of events and you're doing massive scale at origin, you don't want the massive volume to come back, and you're willing to pay the penalty on mass concurrency. And so one example of that, and just kind of showcase for you, we did an event this past year. We have the graphic up on the screen behind us of these two events that went on nearly simultaneously. One of them was, they were both around roughly the same peak of 2.5 terabits per second. One of them was the existing configuration that did not leverage our golden configuration. That had 18 gigabits per second back to our origin. It didn't leverage the AK path. It didn't leverage any of these optimizations that we learned through this collaboration process and through these things that gave us that insight. The other one leveraged the golden configuration, leveraged all of the iterative approaches that we were able to learn over the course of months working together on this, and we were able to get 300 megabits per second at origin. The other thing that might surprise you, one of these was VOD, one of these was live. The live one was less. So those two things together really helped us ensure that we were on the right track when it came to the golden configuration.
Just one more point on this. If you notice the offload, so the other interesting fact about this is how fraction of a percent change in your offload percentage can dramatically impact the request volume to origin. So we're seeing that reflected in these numbers where that 1% just really results in significant performance improvements and protection of our core infrastructure.
So now what, right? So we finally got to that point where we could leverage the APIs, the property manager APIs. And it's kind of funny, in the time that we were working with John Countsman over here from the enterprise architect team, it was during that time that Akamai CLI came out, and we were still wondering, well, could we use Akamai CLI? And unfortunately, we couldn't because of those variables that we brought up before. But one of the things that we did also work with John on was enabling the property manager APIs to work with a Python script, enable us to run it in command line, enable us to have it be completely self-service. and do it for all of our different partners. And so, with the help of people on my team like Alima, we were able to go ahead and configure different versions of our configuration for our different partners. We hard-coded some elements just to make it a bit easier, but all of them could be passed through as variables. And the result of that was, with a couple of variables that we can pass in command line, with the origin, with the publish host name and the CP code, we can go ahead, publish up a configuration for our partners, and have something ready to go to do a live event that does 2.5 terabits per second in a matter of 20 minutes on staging, 40 minutes in production if I didn't want to use fast propagation. And so to really quickly talk through the API right now, we've got John over here. He's going to log in and kind of show you a quick demo of his API, the version of the API that he worked with us to put together. Not the version we use in production, but it's one that works with his demo account. And so I'm going to hand it over to John and slide on over.
Yeah. Is it on?
Yes, it is.
Okay, yeah, thanks, Eric.
Do you want to type and
Yeah, this is extremely
not
small.
make it too awkward?
Okay, yeah, thanks. Yeah, as Eric said, yeah, one of the lessons learned when Eric brought our team in, I'm from the GSS team, and we were doing monthly assessments for BAM, for BAMTech, and one of the lessons learned was that we had all these bespoke configs. They was using like download delivery, HTTP downloads, all these older products, and it was all this hand-edited configs. And over time, we noticed after we did this huge audit of all these hundreds of configs, most of these hand-edited configs were already part of AMD. All these lessons learned from BAMTech and all these other customers were already incorporated into AMD. So there's really no use in duplicating. So we leveraged AMD in the beginning, and we added the HTTP downloads later. So we're really focusing on AMD because as new optimizations are created, all it takes is just the update of the property, a new version, and then you have all the new features immediately.
The AMD baseline templates as well for live and VOD were also flags that we're enabling here. So some of the optimizations that we actually worked on are getting fed back into the product as live optimizations for your own origin.
Right. And then again, we did choose to use a custom script instead of Akamai CLI. As you can see on the back wall, there's basically a running demo of Akamai CLI. And if you look on the left, it is fairly simplistic and it's great for DevOps. And on the right, you can see the input on the wall of what's required to clone configurations. And we're trying to make it as simple as possible for basically anybody to be able to clone these configs with just knowing maybe 2 or 3 options. As Eric said, the origin host name, the CP code, and the new property config. And you could be able to input that either through the command line that I'm going to show you here, and then also, since we did write it in Python, if you wanted to migrate to a web app or something like that, it's super simple. So we're not tied to any particular tool. So
Let's give it a shot.
yeah, so I want to do a demo right here. I have it pointing to my internal account, and of course it's named Edge Demo, and I am going to create a new config called AMD Demo 2, and it's using my playpen, mediaplaypen.com, and then in this case we want 6-second segments. In this case, we're saying that it is going to be a live stream, and then we're pointing to this particular origin.
So John, you're saving all these variables here in a JSON file that's feeding the CLI, correct?
Yeah, correct. I'm basically all the reusable variables, the things that we use every time, like group ID, contract ID, even the email accounts for notification. Those things you don't have to re-enter them every time. If you were using other tools, you'd have to populate all this information every single time. So things that we know we're going to use every single time when we design this, we hard coded into the script so it can be changed. And so we only have to provide the variables that change. So in the case of this, I'm going to use a similar version of their script, and I'm going to do a clone of my golden configuration to a new property. Actually, sorry, let me, I already cloned AM number 2. I want to make it number 3.
Changing the host name here, right?
Changing the host name, right. Yeah. And just to back up a bit, I can talk now with this while it's running. Yeah, just to back up for a minute, the nice thing about using the APIs is I actually started coding this in Perl. This is kind of my go-to language. I've been using it for years. And then I got a working framework set up, and it was doing everything just fine. And then Eric came back and said, "Hey, can you do it in Python instead? Because we know that better." And it was trivial. It just took a couple days because it was just using the Python JSON libraries, going into our Kickstart GitHub library. If you go to GitHub and look for Akamai PAPI API, there's Kickstarts for at least half a dozen programming languages that show you how to start with the authentication, and it gives you a couple of example APIs, and you can just go to the Akamai developer.akamai.com website, and it gives you examples for every single one. And as you can tell here, you notice there was a sleep on here for a minute. We had to put in some specific rules to fully automate this, because some things we have to wait till it propagates. If we were using Akamai CLI, we would probably have to run the command multiple times, because sometimes you have to wait for like a host name to propagate and then tack on an additional piece, and then it would take multiple passes to actually generate the clone. And then as well, MOB, or BAMTech, sorry, BAMTech uses custom certificates. So we had to utilize the Akamai CPS API within this to, if you do flag it as a secure site, then we're able to contact the CPS API, and then we can actually generate a signing request programmatically, receive the signing request back via the API, and then submit it to their signing authority, and then you can automatically submit the certificates back in as a second phase and then continue. So the entire process is automated. And then as you can see here, we actually went through and cloned the entire configuration within the time I was talking. It was just a couple of minutes, and actually activated it. So as you can see here, we got an activation link back. And any minute now, I'll get an email that says it's activated, because they're using fast activation on their account.
Say, why is mine so much slower? And that's why, because this one has fast activation on your account?
Right, this one has fast activation.
That would make sense.
Yeah,
okay.
Yeah, exactly.
We'll walk through we chose to activate on stage, the activation process.
Right, yeah, in this case, we're only activating on staging. In theory, we could activate in production. It's just one additional call. But we don't really want to push out into production without somebody QAing it and just looking over it, maybe doing some test runs on the stream, and then all it is just either going into the API and saying activate in production there, or just going into Luna and clicking activate on production, either way. And then, how are we on time?
We're good. One of the other things too, one of the reasons we didn't choose to do the quick activation to production was simply our kind of process, right? We wanted to put a strict process in place that was one where everything was tested in staging before it went to production, just to ensure that we had strict controls. Even if it was something that was as mild as a standard change, we wanted to ensure that we always had someone looking at it in a staging environment without it first touching production traffic, unless it was something that was completely brand new that had no real-world visibility. And in those scenarios, we occasionally would push it to production, but we would like someone on our team, on the infrastructure team, to first look at it, review it, and touch it, just in case, to have that DNS, first of all, the update DNS, but also to ensure that things flowed through smoothly and had that kind of final level of approval on it. I think at some point we will update the script and do a full production push to it, so that everything is completely automated end to end. But it is, as we've kind of pointed out from the start, it's been a process over the last 6 to 8 months to get to this point, and it's just a matter of continuing that process. So kind of with that, just quickly to wrap up, John's got more on this. If you want to hear more about it and go into a bit more detail, he's doing a hands-on presentation of the automation tomorrow morning at 9 a.m.
The other point, the long-term goal of all of this in our automation is end-to-end, being able to integrate this with other products as well. So with MSL, provisioning ingest channels, bolting it into delivery with the golden config and our AMD configurations, just having that end-to-end, whether it's via a CLI or we're doing other custom types of integration with our publishing workflows on like our CMS. This is definitely the way that we see ourselves scaling to meet the demands of future partner sites and streams. We have some time for some questions. I think we have 5-10 minutes if anyone. 5 minutes for questions. Anyone?
Yeah, it's hard. It's a hard room. Just shout it. So the different variable elements are typically authored based on partner requirements that are provided to us. Some of the host names are driven by either partners or by internal choices that we make, depending on where those marketing decisions come from. The origin authoring themselves, we have a specific team, our core media team, that typically handles and owns origin. But we actually have, and it's not covered, something we covered in here, but it was the one kind of nice framework we had in place was a naming schema that we had. So that naming schema was tightly defined. That enabled us on the edge from day one to quickly take apart and understand if there was a problem going on in real time, where that problem occurred, and also track issues down from edge to origin and easily identify both externally and internally where that problem occurred. And so from that naming schema and from that process, we quickly can build and construct any configuration and any input that we need. So that gives us the opportunity to build and construct the publish host name, the origin host name, and then the CP code we typically just build and construct based on the partner name. It's partner name, property that we're delivering, and typically the product or the protocol. Any other questions?
Yeah, I just wanted to add, as requirements change, which happens often, if we wanted to add like a particular feature that a partner required, like some kind of advanced metadata, we wanted to be able to switch on and off. All we have to do is just add a new property manager variable, which can switch on and off a piece of custom code that might be added. And then all we do is just go into the script and just add that as a flag. Do you want to disable or enable it? And then we just set true or false to property manager variable. So enabling new features or disabling new features based on customer requirements is really simple. And then it's just, like I said, just property manager variables, and then just the flag on the script. And then that's all there is to it.
It's really, just to echo what John says, it's really another way to make Luna kind of work for you, right? It's taking what Luna has in place and the options that Luna has in place and the advanced metadata we can have the Akamai architect team or the Akamai support teams put in place for our configuration needs, and take that to the next level to programmatically now take advantage of those for each and every configuration that we do, just by turning them on or off, effectively commenting them out of configurations we don't need them on.
So we've all these functions and features that we're enabling with the flags, we've tested them, and I think that's the biggest benefit here in how it's deployed. It's been tested, we know it works, and turning it on and off in that way just gives us the confidence that we're implementing it in a standard way across configs. So thank you, everyone. I think we're at time.
Thank you all. Go see John's session tomorrow.
Yes.